So this problem, we are going to write a lot of powers of 2's on each sheet of the card, and then we want to make sure they have the total sum, and then we also want to, the problem is trying to minimize what? The most frequently used power, right? So let's start with this. First of all, I think whenever we write numbers, we can always scale them down, right? So there's no need to write the numbers too big, right? Well, of course, if I write all the numbers are the same, then we have 10 numbers, but then clearly we can reduce that. So what if I start with, say, write a number 4 here, and I can write another 4, right? And I can write another 4, right? And then I have split them into 2, 2, and then what? 2, 2, right? So in this way, so far, all the numbers are written in how many times? 4 times, right? And our total is 8, right? So I try to balance this. I can write lots of 1's now, but not too many 4's and 2's, right? So what do you guys think? I can write.
Well, you put down 4 1's, right? That gives you another sheet of paper.
A 4 and a 1, 1, 1, 1.
Right, just 4.
4 1's.
Yeah.
Okay. So now the rest of them, how do I balance them? I can write out a what?
Well, you can use 1's, 2's, and 4's, right?
Right.
You used already them 4 times. You either increase the number of times you use, or you introduce an 8. But if you introduce an 8, you already have to change your initial.
Right. So I can say, for example, write 1 more 4. So I increase all of them or evenly, right? So I can write a 2 1 1, for example.
But now you have 6 1's.
Now I have 6 1's.
So basically you use another 4.
So that allowed me to use another 4.
Yeah. So now you managed to do it using 6 of each number.
Yeah.
But it's
I almost used the 6 times each number.
the only one is to use 5 2's.
These 5 2's, right? But this gives us some idea about how to reduce them, to balance it out, right? Okay. So,
Well, it seems we did a pretty good job here because, like you said, we used 6 4's, 6 1's, and 5 2's, right?
Yeah.
So we tried to squeeze as much as possible.
as much as possible.
So
right?
I'm wondering, is 6 maybe the minimum that we could use?
Right.
Because why don't you start with 8 and you could have a better strategy, right? More power.
But we realized actually at the end it's the same thing, right? It's whenever you split, you need many, many more to come out, right? So the key still remains here. If I want to split a number here, I need a double, right? If I split it again, boom, I need many, many more to come out, right? So in a scale wise, I know this is actually very close to what? To the optimal case now, because basically 1 to 4 ratio is almost what? Almost necessary. If you don't want to use a power too many times, you reduce it and reduce it 1 more to replace this power you clearly need for, right? So now we are going to try to set up some balance to see how do we really prove this thing. So this is a hard problem in the sense of how do we write up what? Equations, right? So what are the variables? We know one thing. The sum on each card, that's clearly a variable. And then we also know what?
Well,
M is the number of what? Maximum number of what? Times of a power. Right? So those are two what? Two things I want to consider. So how do I set it up? I need to add them, basically, right? So first of all, I basically consider these 10 sums.
Yes.
Right? This 10 sums is adding all the cards this way, by each card, the sum. There's another way of adding these totals. Is by what?
By looking at the powers.
By looking at each powers, how they appear.
Each one can appear more than n times. So the upper part of the sum, when we look this way, is n times 2 to the k plus 2 to the k minus 1 over to 1.
Right. So let's say this. Let's introduce one more thing. The highest power is what?
That appears.
is 2 to the k, right? For example, and m is the maximum number of what? A power of 2.
So this is the highest power of 2 that's less than s. Is 2 to the k.
Right. Maximum number of appearance. Right? So we know is if the highest power is 2 to the k, all the rest of them can appear are those. And each of them can appear at most n times. So that's our inequality because technically that's what it is, right?
So that means that 10s,
10s, which is the sum,
is less than or equal to
is less than or equal to m
times all of those together.
right? This is still not helping me exactly yet because
Well, we can simplify the sum of the powers of 2 because we know that's 2 to the k plus 1.
m equal to 2 to the k plus 1 minus 1, right?
And remember, the goal is to show that m can be 5 because we already constructed m equals 6.
So let's see what happens if we plug in n equals 5.
M equal to 5. You want to show this is less than 1. Okay, let's say m 5 times 2 to the k plus 1 minus 1. This gives you, at least I show something is 10 now. I like that. 10 times 2 to the k minus 5.
Is bigger than 10s, but that's
We don't know that. We want to show m is going to be what? M is more than 5, right? We want to show if it were 5, what happened?
Oh, this is bad, right? Because we said 2 to the k is less than s.
Right. This is the key. I think we are missing a little piece here. We want to actually cancel out what? Some numbers because clearly over here 2 to the k is bad. We cannot carry it to when we do computations. We want to do something only about what? M, right? So we need to replace this s. So the key is what we know. If it's really a high power, there's no need to really bring lots of small power with it, right? So actually this is clearly more than what? 10 times 2 to the k. Because 2 to the k appears in one of the cards, right?
Yeah.
So that sum clearly is more than what? 2 to the k, right? So with all this in mind, then we can know immediately m cannot be 5. Because if m were 5 or less, we're in deep trouble. Because this is 10 to the 2 to the k minus 5, which is what?
More than 10 to the 2.
More, yeah, this number has to be more than this.
Clearly not.
But this number is clearly not, right? So that means m has to be what? More, at least what? 6. And also we already find 6. I think there are other distributions too that make it work, right? So m is 6, right?